Hey everyone, Vibhuti here, and today I'm super excited to walk you through the 14 amazing challenges from the Bharatiya Antariksh Hackathon 2025. Now, whether you are just starting out, still in college doing research, there's something in here for everyone who is even a little bit curious about space, AI, or problem solving. We'll take a quick look at each challenges, what it's about, why it's important, and what kind of ideas they are looking for, and I'll keep it simple, clear, and real. So let's jump in. So, okay, before we begin, just quick overview of what this hackathon is all about. So, Indian space sector is booming right now, and the Bharatiya Antariksh Hackathon is a great opportunity to be part of it. This isn't just about launching rockets; it's about using things like AI, machine learning, and data from satellites to solve real world problems like tracking air pollution, improving agriculture, or even predicting a natural disaster. And don't worry, you don't need to be a rocket scientist to join. If you love building things, you are in the right place. Alright, so let's look at the first challenge here. So, challenge one is simulation modeling of forest fire spread using AI ML techniques. So, this challenge focuses on developing system that can simulate and predict how a forest fire spread over time. The goal is to use artificial intelligence or machine learning to model the behavior of fire based on factors like winds, vegetation, terrain, and weather. The model should help authorities make timely decisions to protect people, wildlife, and resources. And let's move on to the second challenge. So, our second challenge is AI based help bot for information retrieval from a knowledge graph. So the one pretty cool, you're building a smart help bot that can answer questions by pulling info from a knowledge graph. Think of it like ChatGPT, but for the specific portal or domain. So the bot should understand what the user is asking, search the graph, and respond with meaningful, easy to understand answers. Okay, so the challenge is about creating an AI powered chatbot that can answer user questions by retrieving information from the knowledge graph or web. The knowledge graph is built from static dynamic contents of a web portal. Okay, so that is how you have to solve this challenge. Let's move ahead with challenge number three, which is chain of thought LLM system for spatial analysis. So, participants are required to design a system that uses a large language model LLM to solve complex spatial analysis tasks. The model should break down problems step by step, chain of thought, and intelligently orchestrate geospatial tools to arrive at solutions. This is useful for scenarios involving maps, location, and environmental planning. So, yeah. Next, the fourth challenge is monitoring air pollution from space. So, this challenge involves building a system that can monitor air pollution by integrating satellite observations, ground based sensors, historical data, and AIML. The aim is to generate a comprehensive and accurate view of air quality across different regions, helping with environmental health and policy making. Let's move ahead with challenge 5. So, challenge 5 is automated feature detection from satellite imagery. So, here participants must develop a solution that automatically detects and analyzes features such as glacial lakes, road networks, or urban drainage systems using satellite imagery from multiple sources. The system should also be able to identify changes over time to support monitoring and planning. So let's talk about the challenge six, which is cloud motion prediction using diffusion model. So this challenge is focuses on predicting cloud movement using diffusion model applied to satellite imagery from INSAT 3DR 3DS. The goal is to generate accurate future cloud positions which is vital for weather forecasting and atmospheric studies. So let's move with challenge number 7, which is optimizing deep learning and for imbalanced Earth observation data. So participants are expected to explore and implement new methods to improve deep learning models when dealing with imbalanced dataset in Earth observation. The challenge is to ensure model reliability even when certain classes or types of data are underrepresented. So the challenge number 8 is identifying tropical cloud cluster using INS-AT data. So this challenge is about developing an AI/ML based algorithm to identify tropical cloud clusters using half hourly satellites images from INS-AT. Accurate detection of these clusters is essential for early warnings of severe weather like cyclones and heavy rainfall. So the challenge number 9 is identifying HLO-CME events using Aditya L1 payload data. So here participants must create a system to detect HALO coronal mass ejection CMES based on particle data from the SWIS ASPEX payload on board the Aditya L1 satellites. Detecting these solar events is critical for predicting and mitigating the effects of space weather on Earth. Let's move ahead with challenge number 10, which is air quality visualizer and forecast app. So, this challenge aims to build a mobile or web based application that can visualize current air quality and forecast future trends in granular detail, particularly focusing on small cities and rural areas. So, the goal is to make air quality data accessible and actionable. Let's move on to challenge number 11, which is dual image super resolution for satellite imagery. So, participants are asked to enhance the resolution of optical satellite imagery using a pair of low resolution images. Additionally, they must develop a blind evaluation system that can assess the quality of enhanced images without needing a reference. The challenge number 12 is high resolution lunar DEM using photoclinometry. So the goal here is to create a high resolution digital elevation model DEM of the moon surface using photoclinometry, also known as shape from shading. This technique extracts elevation information from the brightness and shading in lunar images. So the 13 challenges is detecting landslides on Earth and the Moon. So this challenge involves developing a methods to detect landslides using Indian remote sensing imagery. The system should be capable of identifying such events on both Earth and the Moon, which helps in geological studies and disaster management. So let's move ahead with the challenge number 14, which is last. So change detection and alert system using LISS4 imagery. So participants are expected to create a system that can detect, monitor, and issue alerts for changes in a user defined areas of interest using multi-temporal LISS4 satellite images. The goal is to track natural or man-made changes and provide timely alerts. So that's it for today. These challenges. So this one is about the we just went through all 14 challenges from the Bharatiya Antariksh Hackathon 2025. So now it's your turn to go pick the challenges that excite you the most and read the problem statement in detail on the official website also and start brainstorming with your team. So good luck everyone. Thank you.